Hey everyone, so the next lesson for this unit is on the angles in the triangles and all about how to find the measures of the angles. So the first theorem that we're going to talk about is called the angle sum theorem. And we've actually already talked about this earlier in the year when we did the angle puzzles in chapter 3. But basically it just says that the sum of the measures of the angles in a triangle is 180. So in this picture here, the measure of angle A plus the measure of angle B plus the measure of angle C would add to 180. So basically we use that a ton in this unit and throughout the whole year really, because triangles never really go. So like in example 1, if we're trying to find the measure of angle T, what we would do, these three add to 180. So we would just add R and S. So 25 plus 35 is 60. And then subtract that from 180. So the measure of angle T would be 120. Okay, so there's like a pretty basic example. Then something like this. Sometimes you have a few angles that you have to find. So same idea, we can find angle 1 first by adding 90 and 58, which is 148. And then 180 minus 148 is 32. So that's this measure of angle 1. Angle 1 and angle 2 are vertical, so those are both 32. And then we have 108 plus 32. So now we're going to, I should probably say what I'm doing. Now I'm going to add these two, subtract from 180 to give us angle 3. So 108 plus 32 would be 140, and then 180 minus 140 would be 40. So angle 3 would be 40 degrees. And so that's how we would solve something like that. The next theorem is called the third angle theorem. The third angle theorem is something that we don't really use a ton to actually find measures of the angles, but you could. Basically, it says that if you have two angles in one triangle that are congruent to two angles in the other triangle, those third angles, so in this case, C and F, are congruent. They're forced to be congruent, right? Because if we add A and B and subtract from 180, it'll give us C. But if E and D are the same as A and B, then that sum will be the same as A and B, and then you subtract from 180 and F is forced to be the same as C. So that's the third angle theorem. The last theorem that we're going to talk about involves exterior angles. So let's first define what an exterior angle is. So an exterior angle is the angle between one side of a triangle, so one side of a triangle, and the extension of an adjacent side. So see how that would be considered an exterior angle. If I were to extend this one instead, that would be an exterior angle. Or it can extend this one instead, another exterior angle, or this one, another, and so on. This one is not an exterior angle. This one, not an exterior angle. Because an exterior angle has to be adjacent to the triangle. So like one of the sides of the angle has to be the side of a triangle. So there's an exterior angle. With every exterior angle, there's a set of what's called remote interior angles. And so the remote interior angles are basically the angles that are inside the triangle, but aren't next to the exterior angle. So here's our exterior angle. Angle 2 is just a linear pair with angle 1. So angle 2 is not a remote interior angle. It's 3 and 4 that are remote interior angles for 1. Now, the remote interior angles are going to change depending on like what exterior angle you're looking at. So let's say I extended this one and I'm looking at this exterior angle. So then the remote interior angles would switch to 2 and 3 because this time 4 is next to it. So it really just depends on the picture. Okay, so we have something called the exterior angle theorem that says the measure of an exterior angle is equal to the sum of the measures of the remote interior angles. So that means the measure of angle 1 here, this exterior angle, is equal to the sum of A and B, because A and B are the remote interior angles for angle 1. So see, measure of angle A plus measure of angle B equals angle 1. So if we look over here, this is an exterior angle, angle 1. And that's what we're being asked to find. Notice R and S are remote interior angles for angle 1. So we're just going to add 80 plus 60 to get 140. And that's the measure of angle 1. That's it. Example 4, remote interior angle, exterior angle. So the two remote interior angles, x and 55, add together to equal that exterior angle. So I'm going to subtract 55 to get that x is 23 degrees. So that's the exterior angle theorem. Okay, next I just have a few examples. So example 5, a few more examples is what I meant. Example 5 is kind of like the one we did earlier, just using mostly exterior angle theorem. So see how 70 and 55 are remote interior angles for angle 1. So if we add those two together, 70 plus 55 is 125. So that's angle 1. Angle 2 and 55 are vertical. So this would be 55 degrees. Now over here, we have, this is an exterior angle, the 150, and then 2 and 3 are, again, remote interior angles. So we're going to have 55 plus, we'll call it x, equals 150. So to solve for measure of angle 3, we're just going to subtract 55. So that would be 95. So that's measure of angle 3. Okay. The last two examples are examples involving algebra. So something like angle 6, these are all interior angles of the triangle. The interior angles add to 180. So all you're going to do is add the three angle expressions. So x plus 4d plus 3x minus 17 plus 2x minus 5 and set it equal to 180. Then from there, we're going to combine like terms. So x, 3x, and 2x, that would be 6x. And then 40 and negative 17, that's going to be 23. And then minus 5 is going to be 18. So that's positive 18 equals 180. Let me switch back to red. So now we're going to subtract 18. So we're going to have 6x equals 162. And then we can divide by 6. And so we get x is 27. Remember, if I asked you to find the measures of the angles, you would just plug in 27. So like over here, you do 27 plus 40. Over here, you would do 3 times 27 minus 17. And over here, you do 2 times 27 minus 5. I didn't ask that here, but that's what you would do if you were asked to find the measures of the angles. Okay, and then the last example, example 7, we're given this exterior angle, and we're given this interior angle and this interior angle. Notice that this 6x minus 7 is not inside the triangle. So you can absolutely not add these three together and set it equal to 180. That's probably the most common mistake that kids make here, is just like once they learn that the angles in a triangle add to 180, then a lot of times kids will just want to, like, no matter the situation, add everything to 180. And that's not what we want to do. So you have to take a look at the situation. These are remote interior angles. This is an exterior angle. So remember the two remote interior angles, 2x and then 103 minus x, those add together to equal the exterior angle. So we don't need 180 at all here. Okay, so now we just have to solve for x. So 2x minus x would be x, and then we have 103. So now I have x's on both sides and constant, so I'm going to subtract x, bring it over here, and then I'm going to add 7 to bring it over to this side. Okay, so this is going to be 110 equals 5x, and then just divide 110 divided by 5, which is 22. And so that's what you do when you have algebra instead of just numbers. You just set up an equation to represent the situation. Either you have all interior angles, like example 6, where you add them to 180, or an exterior angle and two remote interior angles, like example 7. Please let me know if you have questions about anything. I will be on the ACT Lab link all day today, so please don't hesitate to come on and ask any clarifying questions. All right, guys, that's it. Have a great day, and I will see you on Wednesday.